actually it actually have exactly the same partition function as another theory that which have a different gauge group like UN minus M with the same global flavor symmetry. But also you have additional meson field existing in this theory. So this is basically, you can really imagine that today that microscopically you have two different Lagrangian in UV. But they flow in a large distance to exactly the same fixed point in the IR. They are described by the same interacting conformal field theory. So if they are described by the same interacting conformal field theory, you expect their partition function, their index, has to be equal to each other. And that's actually one power of those exact partition functions that allow you to check otherwise very hard infrared physics. But also, we know this theory, as we talked about just now, that this actually also enjoy this kind of hopping symmetry, that is modular invariance when you change the external mass parameter. So we can actually relate it, like basically all these three otherwise different looking two-dimensional field theory. And we can also show that all this nice kind of duality structure also exists in the less symmetric setting. Okay, so that's the last slide, and I just keep the time. So a few directions, and I guess there are some students. So we can extend the analysis here, really trying to study the surface operator in basically those n=1 deformation of the Tn series, like the three punctures, and they are Sicilian series, and actually you have different duality among n=0,2 series. But also, now one can also try to reduce all this 4D index we've been considering, and to perform a similar kind of analysis in 3 dimensions. So the corresponding object we'll be studying are really those kind of monopole loops in 3 dimensions. And then we expect the answer will be basically dominated by basically the quantum mechanics described those monopole loops. And there are whole series of beautiful 3-dimensional dualities one can also check. But finally, I think the kind of missing project here is really that we really want to kind of directly compute the expectation value of all these surface operators in 4-dimensional partition function, or basically the line operator in the 3-dimensional partition function using the localization. This will really require us to impose appropriate boundary conditions that arise from the singularities along those defects, and that would require you to really generalize all this index calculation you learned from the summer school, like over the summer. Okay, so I hope I end here. Thank you. Thank you much for your attention. Questions?
No, look the title, surface defect. I thought you might have some application on this matter system, but it's more the surface defect, the concept in mathematical physics.
Well, so, okay, very good. So what can I say about this? So I think in 3 dimensions, when you generalize this game in the 3 dimensions, that you can have a you can actually have a, I will be looking at some Chen-Simons theory. In fact, okay, I mean more precisely, I'm not looking at this supersymmetric Chen-Simons theory. There will be a dual, there will be another closely related bosonic Chen-Simons theory. And all these surface defects that I'll be looking at will be some kind of Wilson loop that in this Chen-Simons theory. And there, I think they will be much closer to if you want to have some kind of topological entanglement or something like you want to calculate. So, but on the other hand, no. I mean, I think there are applications in condensed matter. For example, just a direct study of a vortex moduli space. And why do we care about moduli space at first place? We are looking at the kind of those vortex tubes kind of moving along the superconductor. We want to know how they actually scatter with each other, right? And how your superconductor actually get lost. And that was actually my first PhD project. Yeah, when I started out and studying precisely those metrics. And I think those exact localization calculations from supersymmetry that actually give a very good, basically very good kind of approximation that to give you the Kähler potential of those vortex moduli space. And from Kähler potential, you can derive the Kähler metric, which is basically your kinetic term of your multi-vortex configuration. And then you can study your scattering, and that's another obvious thing. Yeah.
Any further questions? If not, let's thank Heng-Yu again. Thank you.有没有同学有修课啊？可以啊，可以。有没有同学？
对啊，我实在是觉得我们主要是每次系上去吃饭都5、6千块，不少钱。下礼拜就会。
我知道，我这个看到有一个这样子，我现在我看到不少。